Welcome back, everybody, to the deep dive. And today, we are diving deep into the world of Keydro.
Okay.
So Keydro is a company that is really making some big moves in the hydrogen storage sector. And, our listeners are always on the cutting edge, so they want to get up to speed on what Keydro's been up to.
For sure.
And we've actually got a fantastic set of sources to help us unpack this.
Okay.
We have some information from their website.
Uh-huh.
We're going to take a deep dive into their patent, and we have some press releases that detail some really interesting collaborations that they've got going on.
Well, it is a very exciting time for this whole field.
Yeah.
Finding ways to store hydrogen efficiently.
Right.
That's a really big hurdle that we have to figure out.
Yeah.
We want this to be a major fuel source.
Absolutely. So let's jump into it. I was looking at their website, and they talk about this multidisciplinary approach.
Mm-hmm.
And I don't know about you, but it kind of sounds a little bit mad scientist-y to me.
It kind of does.
They're combining material science,
right,
particle physics, and even fractal geometry.
Yeah.
Like what?
What are they doing with all that?
Exactly. What is going on in their labs?
Well, it makes sense.
Yeah.
If you think about the problem.
Okay.
They're essentially trying to design the perfect material to hold on to hydrogen safely and efficiently, right?
Yeah.
So they're using things like carbon allotropes, which, if you don't know, are different forms of carbon, like graphene and nanotubes.
Okay.
And they're manipulating these structures at the nanoscale.
Hold on, nanoscale.
Nanoscale.
Yeah.
So like really tiny.
Super tiny.
Atoms.
Yeah, manipulating individual atoms and molecules to make these intricate structures.
Yeah.
And one of the really fascinating things that they're doing is something called doping.
Doping,
where they introduce like tiny amounts of other element into these carbon structures to enhance their ability to bind to hydrogen.
So it's kind of like, I'm thinking like baking a cake where you add a pinch of salt to bring out the flavor.
Yeah.
But here they're adding a sprinkle of like boron or something to make the carbon even better at attracting hydrogen.
That's a great analogy.
Okay.
And that's where this intricate design is where the fractal geometry comes in.
Okay.
It helps them create these incredibly complex repeating patterns that maximize the surface area within the material, giving the hydrogen more places to latch on.
Okay, so all of these different disciplines coming together to solve this problem.
It's pretty cool.
It's very cool.
Yeah.
But, it's one thing to have a cool idea.
Right.
It's another thing to have a patentable invention.
For sure.
And Keydro has managed to do just that, right?
They have.
The European Patent Office has officially recognized their innovation. That's huge.
Yeah.
It's a big deal.
And their patent isn't just for any old hydrogen storage method.
Right.
It's specifically for this unique way of creating these nano-perforated and nano-deposited materials, all arranged in this special wafer-based structure. So wafer-based structure, like those silicon wafers that they used to make computer chips?
Exactly.
Okay.
Yeah, and that's important.
Okay.
Because using that wafer-based approach could make scaling up production much easier and more efficient.
Okay.
Which is key if you want to bring this technology to the masses.
Okay, so they've got this super advanced material designed at the nanoscale and a way to potentially mass produce it.
Yeah.
But what does it actually do? Well, what are the big claims in this patent?
One of the biggest is the ability to store hydrogen at room temperature with minimal external pressure.
Okay. Now that's a big deal, right?
That's huge.
Most hydrogen storage
methods today rely on incredibly high pressures or cryogenic temperatures.
Exactly.
Which are both expensive and energy intensive to maintain.
Yeah. So if they can make it work at room temp and low pressure, it would open up so many more possibilities for using hydrogen as fuel.
Yeah, totally.
And it's not just speculation.
Right.
Their patent application went through the international extension process, meaning it got scrutiny from patent examiners all over the world, and it still passed.
Wow.
They even got a positive assessment from the PCT search report, which means experts in the field see merit in their claims.
That's seriously impressive.
Yeah.
But you know what they say, the proof is in the pudding.
Right.
So are they actually putting this technology to the test?
They are. Okay, they absolutely are. And that's where things get even more interesting.
Let's hear it. They've partnered with some leading institutions.
Oh, wow.
To move this from the lab to the real world.
Okay, so tell me more about that.
Well, one of the partnerships that really caught my eye is with the University of Pavia's chemistry department.
Okay.
They're working together on this crucial step in the process.
Okay.
Activating these carbon-based materials.
Okay, so before these materials can become super efficient at storing the hydrogen, they need to be activated.
Yes, you got to activate them.
Okay.
It's kind of like prepping a sponge before it can soak up water.
So what's involved in this activation process?
Traditionally, it's been using these things called shuttles.
Okay.
Made from potassium hydroxide, KOH, and alumina.
Okay.
But the problem is that those traditional shuttles can sometimes contaminate the carbon materials, which is not ideal.
So it's like trying to bake a cake, but your mixing bowl keeps adding unwanted ingredients to the batter. That doesn't sound very efficient.
No, not at all.
Okay.
But Keydro has developed specialized vessels for this activation process.
Okay.
And Professor Chiara Milanese, who leads the hydrogen lab at Pavia, is super impressed with the results.
What kind of results are we seeing?
According to her, these new vessels are non-reactive, which means no more contamination.
Got it.
And on top of that, they're producing super activated carbon that's 1.5 times better at storing hydrogen.
So not only is the process cleaner, but it's also way more efficient.
Exactly.
Wow.
And there's another bonus. The kinetics are twice as fast.
Oh, wow.
Meaning the activation process happens much quicker.
So they're getting more storage capacity, a pure product, and it's all happening faster.
Yeah, it's a win-win-win.
That's amazing. Okay.
Yeah.
So Keydro is making serious progress with this university partnership. But what about real-world applications? Are they working on actually building a hydrogen tank using this technology?
They are.
Okay.
They've also teamed up with the Italian National Research Council, the CNR.
Okay.
And together, they're developing a proof of concept for a hydrogen tank.
Okay.
That operates at room temperature and low pressure.
So this is a big deal.
It is a big deal.
They're taking the technology out of the lab. And moving it closer to becoming a real product.
It is.
That could be used in cars and homes.
Right. All sorts of things.
All sorts of things. That's amazing.
Yeah. And they're very methodical about it.
Okay.
They've set up a dedicated laboratory. And they're focusing on 3 key aspects.
Okay.
1, characterizing these nanomaterial filters.
Okay.
2, designing the storage system itself.
Okay.
And 3, figuring out the release mechanism.
So how to get the hydrogen out of the tank?
Exactly.
When you need to use it.
That's right.
Okay, it sounds like they're building this high-tech hydrogen storage puzzle piece by piece.
That's a great way to put it.
And they seem to have assembled a pretty great team to tackle this.
They do.
Jacopo Sagramoso, Keydro's CEO, seems very optimistic.
He is.
He acknowledges the challenges, but he's confident in their team's expertise.
Right.
And the thoroughness of their research.
Right. They've done their homework.
It sounds like the CNR is equally enthusiastic about this collaboration.
Absolutely. Fabio Di Pietrantonio, a senior researcher at CNR, has emphasized their commitment to advancing this kind of research. They see it as a major step towards making hydrogen storage more efficient, safe, and sustainable.
And both organizations are already talking about extending the collaboration further.
That's fantastic.
Okay, so it sounds like Keydro has ticked a lot of boxes. Cutting-edge technology, a solid patent, strong partnerships. It's almost too good to be true.
Right.
Are there any downsides to this approach?
As with any new technology, there are always challenges to overcome.
Right.
One thing to consider is that we've been mainly focused on Keydro's specific approach, which is just one piece of the larger puzzle. That is hydrogen as a fuel source.
Right.
I think it's important to zoom out a little bit.
I'd love to zoom out. I'm curious to learn more about the bigger picture here.
Sure.
Why is hydrogen such a promising fuel source in the first place, and why is storage such a big hurdle?
Well, hydrogen is attractive for several reasons. First, it's incredibly abundant. It's literally the most common element in the universe. Second, when you burn hydrogen, the only byproduct is water.
Oh, wow.
It's incredibly clean.
Very clean.
And finally, it can be used in so many different ways. From powering cars and homes to generating electricity, and even as a feedstock for industrial processes.
So it sounds like hydrogen has the potential.
It does.
To revolutionize the way we power our lives.
It really does.
But if it's so great, why aren't we all using it already?
That's where the storage comes in.
Okay.
Hydrogen is a very light gas.
Okay.
So storing it efficiently requires either compressing it to really high pressures, which can be dangerous, or cooling it down to incredibly low temperatures to turn it into a liquid, which is expensive and energy intensive.
So that's why Keydro's focus on room temperature, low pressure storage is so significant.
That's what they're trying to solve.
Okay.
They're trying to make hydrogen storage more practical and affordable.
Yeah. Okay, so let's get back to Keydro's collaborations for a moment.
Okay.
We talked about their work with the University of Pavia.
Right.
But I'm curious to learn more about the specifics of their project with the CNR.
Okay.
What exactly are they working on, and how does it relate to the bigger picture of hydrogen storage?
So they're developing a proof of concept for an actual hydrogen tank.
Okay.
And they're being very systematic about it.
Yeah.
They've broken down the project into 3 main areas of focus.
Okay, bring those down for me.
First, they're putting a lot of effort into characterizing those nanomaterial filters we talked about earlier.
Right, the ones that make sure only pure hydrogen gets into the tank.
Exactly.
Okay.
They're using really advanced techniques to analyze these filters at the nanoscale.
Wow.
Mapping out their structure and testing their performance.
So it's like creating a blueprint of these microscopic sieves.
That's a great analogy.
To understand exactly how they work.
Yeah.
Okay, what's the second one?
The second area is all about the storage system itself.
Okay.
This is where Keydro's patented technology comes into play.
So they're actually building a prototype tank using these new materials.
They are.
Wow.
And this prototype is designed to operate at room temperature and low pressure, which, again, is a major departure from traditional hydrogen storage methods.
Right.
It's a totally different approach.
Yeah.
And they're having to develop new engineering solutions to make it work.
That's really cool.
It is.
Okay, so that's 2 down. What's the third piece?
The third area is the release mechanism.
Okay.
Figuring out how to get that hydrogen out of the tank safely and efficiently when you need to use it.
Because you don't want a sudden rush of hydrogen gas every time you need to power something.
Exactly. You need it to be controlled.
Right.
So they're working on a very precise and controlled release system that can deliver the right amount of hydrogen at the right time.
Okay. It's pretty impressive how they're thinking through every detail.
It is.
So they're developing these cutting-edge materials, they're building this prototype tank, and they're figuring out how to safely release the hydrogen.
That's right.
It seems like a lot to handle.
It is.
But it sounds like Keydro and the CNR are both pretty confident in their ability to pull this off.
They are. They've done a lot of work to get to this point.
It's exciting to think about that this technology could actually have a real impact on the world.
It really could.
But let's shift gears for a moment and talk about the bigger picture of hydrogen as a fuel source.
Okay.
What are some of the potential applications that Keydro's technology could enable if they're successful?
The possibilities are pretty mind-blowing.
Okay, let's hear it.
One of the most obvious is transportation.
Okay.
Imagine cars, trucks, buses powered by hydrogen fuel cells that emit only water vapor.
So no more greenhouse gases from vehicles.
That's right.
Wow.
And with Keydro's technology, these vehicles could be refueled quickly and easily, just like gasoline cars today. And they wouldn't require those big, heavy, bulky tanks.
So we could say goodbye to gas stations.
Potentially.
And hello to hydrogen stations.
That's possible.
That's really cool.
And it goes beyond cars.
Okay.
This could power larger vehicles, too.
Okay.
Like trucks, trains, even ships.
Which are much harder to electrify.
Exactly.
Okay, what about other applications beyond transportation?
Or in another area with huge potential is portable electronics.
Okay.
So imagine laptops.
Yeah.
Smartphones, tablets that run for days or even weeks.
Wow.
On a single charge.
That would be a game changer.
You would.
No more worrying about your phone dying in the middle of the day.
Exactly, because with Keydro's technology, we could have tiny, lightweight hydrogen fuel cells that provide way more energy than current lithium-ion batteries.
What about larger scale energy storage?
That's another really promising area.
Okay.
As we transition to more renewable energy sources like solar and wind,
right,
we need ways to store that energy.
Yeah.
When the sun isn't shining or the wind isn't blowing, Keydro's technology could help us create these massive hydrogen storage systems that can hold vast amounts of energy ready to be released when needed.
So it's like this giant battery for the power grid.
That's a great way to put it.
Smoothing out the bumps in renewable energy production.
Exactly.
That's fantastic. And, because hydrogen is so versatile, it can be used in a lot of other ways, too.
Absolutely.
We could use it to power homes and businesses, generate heat, even as a feedstock for industrial processes.
There's so many possibilities.
It really sounds like it could be a game changer.
It could.
But you said earlier that there are still challenges to overcome.
There are.
What are some of the biggest hurdles facing the widespread adoption of hydrogen as a fuel?
One of the biggest is cost.
Okay.
Currently, it's still more expensive to produce and distribute hydrogen compared to fossil fuels.
Okay.
But as the technology improves and economies of scale kick in, that cost is expected to come down.
So it's a bit of a chicken and egg problem.
It is.
We need more demand for hydrogen to bring down the cost.
Yeah.
But we also need lower costs to increase demand.
It's a classic problem with new technologies.
Absolutely. What
Another challenge is infrastructure.
Okay.
We need to build out a whole new network of pipelines, storage facilities, and refueling stations to support a hydrogen economy.
Yeah.
And that's a huge undertaking.
Yeah,
it will require a lot of investment.
It's a massive logistical challenge.
It is.
And also a huge opportunity to create new jobs and industries.
Absolutely.
Okay.
And then, of course, there are safety concerns that need to be addressed.
Right, because hydrogen is flammable.
Right, it's a flammable gas.
Yeah.
So we need to handle it and transport it safely.
But, there are already strict regulations in place.
There are.
For hydrogen. And the safety technologies are constantly improving.
That's right.
So it sounds like there are definitely challenges.
There are.
But they're not insurmountable.
Not at all.
What would you say to people who are curious about hydrogen and its potential role in a sustainable future?
I'd say it's definitely a technology worth watching.
Okay.
It has the potential to transform how we power the world and to help us fight climate change. And companies like Keydro are leading the way.
Yeah.
It's a very exciting time to be following this field.
Well, this has been an incredible journey.
It is.
Into the world of hydrogen storage. We learned so much about the science, the technology, the challenges, and the incredible opportunities that lie ahead.
It's really promising.
A huge thank you to you for
thank you.
Sharing your knowledge and expertise with us today.
My pleasure.
And to all of our listeners out there, thank you for joining us on this exploration
of Keydro and the future of hydrogen storage.
It's been fun.
We hope you enjoyed this deep dive.
Yeah.
Stay curious.
Stay curious.
And we'll catch you next time.